Alright, so we are going to do section 3.3, which is systems of inequalities. This is going to be very similar to the first section we did, the graphing linear systems. The only difference is these are inequalities, so we will be shading, and you'll want two different colors today. And then also, we are going to introduce the V's, or the absolute value functions, back with this. The notes are a little long, and the recording device only allows me to do 15 minutes of recording, so there will be two different videos you will need to watch. So this is the first set. And just a reminder, when we're graphing lines, that there are two different ways to graph. One, I might give it to you already in slope-intercept form, so that y equals mx plus b, which is really, really nice. We always start with the y-intercept on our y-axis, and then we use the slope. Sometimes we have things in standard form. I taught you how to graph that using intercepts, that's plugging in the zeros, or you can change it to y equals mx plus b. Either method works. The one thing that I want you to definitely review, because we didn't see a whole bunch of this in chapter 2, is horizontal lines. We talked about this being HOI. Horizontal line, slope is 0, y equals some number. That will be a horizontal line. And then VUX, remember vertical lines have an undefined slope and they start with x equals some number. So just keep that in the back of your head because you will see those today. Another thing you will see is absolute value graphs. Just a reminder that you need 5 points for those. We learned two methods again. So when you have it, and when you have an equation set up like this and the slope or the m part of x is 1, you can use the translation method, meaning our inside joke here means you move left to right. If it's positive, we go to the left because we like left-handed people better. If it's negative, we're moving to the right. The outside numbers are vertical translation, up or down. If it is positive, we're going up. If it's negative, we're going down. And remember, this only works once again when the slope is 1. The vertex method works all the time. We just take the inside of the absolute value, set it equal to 0, and solve for x, which would end up being opposite b over m. And then that c term is the y part of that vertex point. You do need 5 points, so then remember we did a t-chart to find our other points, and you can mirror those points along the way. Also, we talked about inequalities in chapter 2. You just graphed one inequality. We're going to up it to 2 since we're doing a system. Just a reminder, greater than or less than, so this is going to be a dashed line. If you see that or equal to underneath the inequality, those are going to be solid lines. You can do the above or below shortcut. Remember that only works when y is by itself on the left. When in doubt, choose a test point, and I'll go over how to do the test point again today. So we're going to go ahead and jump into our first example. We are going to graph this system of inequalities. So if we look at our first equation here, this is not in slope-intercept form, and since the method most of you prefer is to change it into slope-intercept form, I'm going to go ahead and do that. If you want to use the intercept method, which is my favorite, continue to do that. I'm going to subtract x from both sides. Negative 2y is less than negative x plus 6. And then from here, we're going to divide by negative 2. So I get y, and negative divided by negative is positive, so this is a positive 1/2 x minus 3. And I didn't write the inequality sign because I divided by a negative, meaning I have to flip the sign. So just a reminder, if you divide by a negative or multiply by a negative, you will need to flip the sign. Graphing our equation here, we have our y-intercept at negative 3, and our slope is 1/2, meaning we're going to go up 1 to the right 2. And when I graph this, notice it doesn't have the or equal to line underneath, meaning when we graph it, we need to use a dash line. So here's my dash line. And then we need to talk about shading. To shade, we're going to use a test point. So remember, a test point is any point on the graph as long as it doesn't lie on one of your lines that you're graphing. My favorite go-to is 0, 0. When you can't use that one, just pick a set of positive numbers because we're typically much better working with positive numbers. So if I plug in 0, 0 into my original equation here, This simplifies to 0 is less than 6. This is indeed true, so I'm going to go ahead and shade with the test point because this is true. So that means we will shade above. Our second inequality is really nice because it's already in slope-intercept form. So we can just go straight into graphing. The y-intercept is 5. So we can plot that one there. And then the slope is negative 3 over 2, meaning we're going to go down 3 to the right 2. Notice these two lines do intersect at a nice solid point, but that's not where our solution lies. I'll show you where our solution lies here once we finish our graphing. So we do need to graph our line. This does have the or equal to line underneath, so it will be a solid line. And then we have to decide where to shade. Once again, I'm going to use my test point method here, and we plug that into the original. And 0, 0 is available to use, so you can bet I'm going to use it. 0 is less than or equal to 5. That is a true statement, meaning we want to shade with our test point. So that would be below our blue line. So with inequalities, the solutions are going to be solutions where both graphs overlap. So if you look at my picture here, it looks like there's a shade and overlap in this region right here that I highlighted in yellow. That's where our solutions are going to lie, all through here. That's why I want you to use two different colors when you're graphing. So when I see the two different colors overlap, that's where I know your solutions are going to be. So you don't have to tell me the points of intersection or anything like that. I just need to see the shaded region. So going on to our next example, these are really nice. They're already in slope-intercept form, so we can go straight into graphing. So looking at our first one, the y-intercept is negative 6. And then our slope is 3, meaning we're going to go up 3 to the right 1. If we look, the inequality is or equal to, so we will want to graph a solid line here. And because y is by itself on the left, I'm not going to do the test point method. You definitely could, but I am just going to go ahead and do the shortcut above or below. So since it is a less than or equal to, that means we would be shading below. So I'm going to shade below my graph. Looking at our next one, it is also in y-intercept form, so we're going to go straight to graphing our y-intercept at 2. Slope is 3, so we're going to go up 3 over 1. Now when I graph this line, unfortunately there's not that or equal to, so I do need to use a dashed line. Y is by itself on the left, so you can do that above or below shortcut. It's a greater than sign, meaning we would shade above. So there's my shading, and if you look, there is no overlap of shading, which means in this problem, there is no solution. And if you think back to that first section, anytime we had parallel lines, there would be no solution. And I want you to get out of that mindset, especially with inequalities. So I'm going to just do a quick little drawing here on the bottom. But let's say if we graph that first equation and we were to shade below. But if our second equation, if for some reason the inequality symbol was switched and I had to shade below, there is an overlap. We would be overlapped down here on the bottom, so there would be a solution. So just because you see parallel lines today doesn't necessarily mean it will be no solution or not. That is going to conclude part 1 of notes. Go ahead and close out of this one and open the second video.